Okay. Question 21. This one is also Form 4, Chapter 6. Okay. So, Table 4 shows the pH values of two acids with the same concentration. So, you see, nitric acid and sulfuric acid, pH value is 3 and 1. Now, you might be wondering, why sulfuric acid has the lower pH value? 为什么 sulfuric acid 的 pH value 比较低？ Okay. So, in this case, normally pH value lower means the acidic properties it means it's stronger the acid, right? So in this case, okay. But I thought nitric acid, HNO3, acid nitric, and sulfuric acid, both are strong acid. But why is it sulfuric acid even stronger? Now, you know why? Because HNO3, if you put inside water, ionize only produce 1 mole of hydrogen ion. So this is called monoprotic acid. Monoprotic acid. For sulfuric acid, you will get 2 mole of hydrogen ion for H2S4. So this is called diprotic acid. In Malay, it's acid monoprotic. In Malay, it's acid diprotic. So in this case, okay, basically, monoprotic means one acid you will get 1 H plus. Di means one acid you will get 2 H plus. So why is the pH value of sulfuric acid is lower than nitric acid? Sulfuric acid is strong acid? No, it's not the best statement because both are strong. Wrong. Sulfuric acid is diprotic. Okay, correct. So it says B. Okay, no, others need to see already. Okay, lower concentration wrong. Okay, double concentration of HCl is correct. Double, twice the concentration of HCl. Twice more than HCl. Not lower, it's higher. Okay, lower is wrong. Okay, 22. Diagram 8 shows, this is also Form 4, Chapter 6. Diagram 8 shows a hydrochloric acid solution prepared by a chemist. Okay, so this one is 6.6 standard solution. In Malay, it's larutan piawai. Okay, so what is the volume of distilled water that needs to be added to the stock solution to prepare the acid solution as shown in diagram 8? Okay, so in this case, okay, let's look at this. Okay, so added, okay, volume of distilled water added to the stock solution. Okay, it means it's like, maybe it's a bit too far, right? So I link to the normal situation. This is your Milo water. You add more water. What do you do? It will decrease the concentration of Milo, right? It means decrease the concentration. We call it dilute. Dilute means to make it more watery, less Milo, to make it more watery. Okay, so the process is called dilution. In Malay, it's called in Malay, it's called, I suddenly forgot, okay, but it's okay. So in this case, later if I thought I tell you that. So dilution, okay, what happens is, the formula got one, it's called M1V1 equals to M2V2. Now, in this case, actually it's supposed to go like this. Supposedly, the number of mole equals to the number of moles. Okay, number of mole equals to number of mole. So in this case, it means one of the formula for number of mole is mv over 1000. So do you know what you got equal? What does it mean by equals something equals to something? This one, right? This one is before adding water. Before adding water. Okay. In front is before. Wait, before adding water. The other one is after adding water. Right? So you see, you might think, is really MV of 1000 equals to MV of 1000? Now, in this case, yes. Okay. So the mole of before should also be equals to after. But the value of M and V will change. You see, very simple one, right? At the beginning, before add water, let's say the solution is 50 cm cube. What my pen like this one? Before adding water, 50 cm cube. After add water, of course, it will increase on maybe like 100 or maybe like 200 cm cube also. So of course, volume before is not equals to after. So it's why you have to give like M1V1 equals to M2V2. M1V1 means before adding water. M2V2 means after adding water. So in this case, means M1V1 means 加水之前 M2V2 means 加水之后啦。So in this case, okay, the reason no more 1000 because 1000 cancel, right? M and V cannot cancel because different value. So in this case, that's why you will get this formula. So what is M1V1 at the beginning? Okay, this one is actually this one is prepare. See, now you see, you read the question. To prepare the acid solution as shown in diagram 8. Okay, to prepare the acid solution as shown in diagram 8. So in this case, means to prepare something. Do you think it's M1V1 or M2V2 given? Result, prepare something to get the result. So it's supposed to be the given here, the diagram to prepare it means you got V2 and M2. V is volume, M is molarity. So they give you that molarity is 0.1 mole per cube. Volume is 250 cm cube. Okay, so you already know you can substitute inside already. M2 is 0.1, V2 is 250. Then they give you also 2.0 mole per cube stock solution. Stock solution means the beginning. Okay, the beginning, the stock solution, the beginning is the M1. This one is M1, so it's V2, M2. So they give you M1 is 2.0. It means V1 is the one that you want to count, isn't it? So how do we get V1? V1 is 0.1 times 250. Move to the left side, become divide 2.0. So what do we get? Let me type calculator. Hold on. So 0.1 times 250 divide 2. So you get 12.5 cm cube. Now, for those who I say like 99%, okay? Just circle A only. But you miss one thing. There's one problem, okay? Because you have to read back the question. What they really want, okay? Now, V1 is the beginning, the water. Let's say it's 12.5. Then after you add water, right? Oh, then after that, you will get 250 cm cube, right? Then you see, very simple one, right? If the volume increases, the concentration, we'll call it the molarity, decreases, right? But you see what they ask. Volume of distilled water added. Not the V1, not the V2. Okay, so it means how much from here at the beginning to reach 250, how much added? So it means what do you do? Minus. It means your final answer is 2. It means is V2 minus V1. Then only correct. 250 minus 12.5. You added 237.5 cm cube of water is the final answer. Yeah. So I saw many students circle this one. Yeah. Okay. So it means this tells us that you have to read the question properly. And also you have to understand the concept. Right? Yeah. 23. Understand? Anybody lost? No. Question 23. This one is Form 4, Chapter 3. Okay. This one to find empirical formula. If you see this, you have to know, you will find the formula through the drawing of table, right? So I straight away draw a table for you. Okay, I draw the small mini version because it has limited space. Like this. Okay, so 1, 2, 3, 4, 5, 1 more. 6. Okay. Lah. Okay. So remember, what do we label? To find empirical formula? The element. Second is the mass, the GSIM. The unit gram. Third is the number of mole, bilangan mole. Number of moles. Unit is mol. Fourth is the ratio, right? The ratio, The ratio is mole ratio. In English, in Malay is nispa mole. Fifth, nispa teringkas, simplest ratio. Six, formula empiric. Empirical formula. So what do you do? First one. Write down. Okay, see 1.5 gram obtain the information. 1.5 gram of X burn completely. You will get 3.1 gram of oxide of X. It means you got X and O to calculate. Normally I write X first. X, then you write O. Then the X is 1.50 gram. Do you think O is 3.10? You read properly. 3.1 gram is oxide of X, means X plus O is 3.1 gram. So what is the mass of oxygen when X is 1.5? Minus that. So total 3.10 minus 1.50. Right? Then number of mole, mass divide molar mass. So 1.50 divide 31. Yeah, for X is 31. So mass divide molar mass. GSIM divide GSIM molar. This one same thing, 1.60 divide 60. 0.1 obviously. 1.5 divide 31. You will get 0.0483. 484 after round off. Right? So I do always divide the smaller more. Of course, 0.04 is smaller than 0.1. So it's 0.10 if you want to be more precise, right? So it means it means both divide by 0.0484. So it's 1, obviously, divide the same thing is 1. This one you will get 0.2. Around 0.2 lah. Okay. So, why do I get 0.2 lah? Oh, wait, sorry, not 0.2. 2.5. No, not 2.5. 2.0. 2 lah. Okay, you get 2. 2.02 lah. Okay. So that's why in this case, 1 to 2. Right? No decimal means, it means this one you round off lah. Okay. 2.06 lah. Let it become 2 lah. Okay. Very near 2 lah. Round off to 2. So you will get XO2. A. Let me check the answer. 23A. Okay, correct. Okay. XO2. This one paper, I have to know how to do. Of course, in paper 2, you write answer. Okay. And then, question 24 is Form 4, Chapter 6. Okay. This girl has been stung by a jellyfish. Jellyfish sting has the pH value more than 7. Okay. She's in pain. Okay. pH value more than 7 means what? The sting is alkaline, the poison is alkaline. So how do we treat it immediately? What should we apply on the wound caused by the jellyfish? Okay. So do you think you should add more alkaline? Obviously no. Okay. Obviously no. So but how do we neutralize the alkaline? Okay. In Chinese, there's one word called 以毒攻毒lah. Okay. It means use poison to cure poison, but it's not correctly applied. But in this case, to use something acidic to neutralize the alkaline sting. Okay, terbalik is sometimes if the sting is acidic, then you use alkaline to treat. If the sting is alkaline like this here, okay, of course you have to use something acidic. Of course, answer is B lah. Okay, vinegar is acidic. Okay, toothpaste alkaline. Okay, so the best answer should be B lah. Just in Chinese means 酸性可以减掉，可以把碱性中性化。In English means like the acidic can reduce the amount of alkaline sting to make it become neutralized. Okay. 25. This is Form 4, Chapter 7. The following chemical reaction represents a reaction. Which of the following is the change to determine the rate of reaction? Okay. So in this case, normally this one is acid. React with water to get. Why did you have water? No, sorry. Metal Metal, logam. Wait, let me think. Let me. Uh, give me 1 second. Okay, so means metal react with water. Correct. Actually, it's correct. Okay, metal react with water. Yes, you learn in group one, right? Sodium, just like I told you, right? Sodium, potassium, lithium, same thing. React with water. Because all these like group one, group two metal, right? They are actually alkaline metal. Okay, you will get the alkaline solution. Okay, and hydrogen gas. But the important one is not the alkaline solution. Is how much of volume of hydrogen gas measured. Okay, which of the following is the change to determine the rate of reaction? Okay, remember the experiment? You use the burette, immerse in water, then you record how much of volume of H2 has produced。还记得你要用那个 burette 蒸进去那个水那边，然后你要量多少个 cm³ 的 volume。It means in each 5 minutes, I mean 5 minutes, in each like 30 seconds, normally you measure, isn't it? In each 30 seconds, you measure how much of volume of H2 produced. Right? So we focus on this thing. We focus on volume of H2. So the answer is A. Right? Change in the volume of gas per unit time. You use time to measure how much of H2 produced. Okay? Not measure this. No, normally you measure the gas, the volume of gas produced, not the solution, not the magnesium hydroxide. No. But actually C can, okay. How much time does it take for magnesium to dissolve in water? Actually can. But the thing is, the problem is, it's not increase. Because magnesium dissolve, right? Got magnesium become no magnesium, right? They say got 5 gram become 0 gram. Do you think is increase or decrease? Decrease. You can use two things to measure mass of the reactant, the decrease of mass of the reactant, or the most common one, the increase in the volume of H2 or Cl2. So normally you measure the volume of gas. 26, Form 4, Chapter 7. This one, many students fail in chapter also. Okay, many students wow, see this question so happy. Oh, like this Oh, I can see that after 50 cm³ stop increasing. Oh, so I know the ratio is between 0 to 180. So I use 50 cm³ divide by 180, I get the answer. Okay, so the answer is wrong because the question is not asking the average. It's not the overall reaction. It's not overall. Overall means like keseluruhan total. But they ask for second minute. That's the problem. Okay. So if they ask for like overall, in Malay it's called keseluruhan. Then you can just use divide on it. Volume divide by time. Finish. Get answer. Finito. Okay. But here no. Do you know what does mean by second minute? Okay. So you see in this case, what is first minute? What is second minute? First minute means from where to when. First minute means from 0 to 60 seconds. This is called first minute. Second minute means what? Second minute is from here to here. From second minute is from 60 second to 120 second. Or in minute, it's called the first minute to second minute. It's called the second minute. for those who watch football, okay, because I'm the fan. So for those who watch football, you notice, okay, sometimes they will announce, if they announce, if the player score a goal at, let's say lah, randomly, 2 minutes and 37 seconds. So they mentioned that guy, if it is round off form, right? They mention score at third minute. Score at third minute. Okay, they put like this in short form. Okay, because this range of time is in third minute. Third minute means from 2 minutes to 3 minutes, from 120 seconds to 180 seconds. Understand? Same thing. Second minute means first to second. First minute means 0 to 1 minute. Understand? So you have to use, what we have to do is, the rate of reaction, right? You have to use 42.0 minus 27.5 divided by 120 minus 60 seconds. That will be your final answer. Yes. So you will get 25 divided by 60, you will get 0. 25. Not 25, 50, sorry. 15 divided by 60 seconds, you will get 0.25 cm cube per second. So the answer is donkey. Can? Yeah, these are the minor things you have to know. Okay. Question 27. Form 4, chapter 7. Which of the following statements explain the situation above? Pressure cooker cooks beef soup faster. In this case, okay, pressure cooker. Okay, I'm normally talking about, if you see pressure or temperature, normally they relate kinetic energy. You know, we learn in physics, right? So the syringe, okay, if you push very hard, so you put a lot of pressure, so it means the kinetic energy will be very high, very active. So if you see pressure, if you see temperature, right? If you see in Malay, if you see tekanan, if you see suhu, then you relate to tenaga kinetic. Okay, so in this case, but you see, activation energy decreases. Okay, not the best answer. Okay, because normally catalysts used for, normally activation energy used for catalysts. Normally used for catalysts. If you got catalysts, not for this factor. Okay, in Malay it's called tenaga pengaktifan, 是用来 for 那个锰金的催化剂。Okay, and then B, kinetic energy correct, but of course it's not decrease, it's increase. So B is wrong. Okay. C, frequency of effective collision between particles increases, correct. Okay. So it means same thing if you boil the water. Boil water means temperature increase. Okay. Then your particle have very active means collect more frequently. Collect more frequently like this. Collect more frequently. Okay. So it means in Chinese means 撞击的频繁率越高啊。Let's say 你煮一个汤，let's say 你煮开水啦，OK，就是弄热那个水啦，那个水就会开始滚，就会那些 particle 就开始撞得更频，like that，OK，collect more frequently. Donkey, total surface area exposed to collision increases. Wrong. This one is used for size. This one used for size. 用 la loss program 用在 size 那边的大小的。So the best answer is C 啊。Collect means collect. Frequency means how frequent they collect. How often. Okay. Page 28, Form 4, Chapter 8. Okay. Which of the following glasses is suitable to be used making the pot in diagram 10? So this one very simple. Okay. This glass making the pot. You see the pots. You see they are cooking, right? Of course, it has a very high temperature, isn't it? 疏忽有3个定义. So it means you want, of course, you want the glass that can tahan all the heat, resist all the heat. Okay, this glass they added boron oxide to make the glass to become more resistant. 它加了 boron oxide， 它的 formula 是 B2O3。OK， 所以可以tahan 更多热能，因为你煮东西嘛。Okay, of course, when you're cooking, you have to have the glass that tahan a lot of heat, so that it won't crack easily, it won't expand easily. So the best answer is B. Borosilicate. Normally, a lot of things can use, okay, borosilicate glass. This one is Form 4 Chapter 8, 8.2, okay, glasses. So borosilicate can make your cooking, some of the cooking pot, cooking lid, okay. What else? You know the laboratory glassware like boiling tube, all this. Okay, also can tahan heat. Okay. Then C. Okay, C, soda lime glass. This one cannot tahan heat. Soda lime cannot tahan heat. Normally, okay, soda lime cannot tahan heat. Soda lime used for like, your jug your glass bottle example 酒瓶等等的，那些不是能tahan热的 ，cannot tahan heat 嘛。Physics glass normally used for like telescope. Okay, 望远镜。Lead crystal normally used for like like some crystal okay, some crystal or some like car headlights example okay. Yeah, I think that's it Okay, can go look back. Okay, what is the uses? Normally, this one is require more like memorization also. This part is you read through, memorize. Okay, what is the uses? But normally you see glass pot is borosilicate gas. You have to know the situation. Borosilicate gas normally can tahan heat. Yeah, and also suitable use for cooking. Okay, and then question 29. Form 4 Chapter 8. If you see this kind of like photochromic glass, it's like a car window, it's like a sunglasses. Okay, when you wear or some camera lenses, okay, or when you wear the glasses, okay, it can block the sunlight from entering into your eye because it added the very important material called silver chloride. Okay, so silver chloride, what is the silver ion able to prevent, or you can say able to absorb the UV light. Because you know, right? Why some of your car put a lot of like, you have to wear sunglasses outside when you're driving the car, when you go outside, very hot. Or why you want to protect your skin, okay, by applying the sun cream to your skin, all this to protect your skin, protect your eye, all this. Okay, so in this case, yes, they added silver chloride to make photochromic glass, okay, to block the harmful UV rays. In Chinese is 它要防止那个紫外线侵入我们的眼睛、皮肤那些，OK， 防止我们被紫外线晒到。OK， So yeah, don't care. Photochromic glass normally added silver, correct? Okay, of course, the main component of glass is silicon dioxide. Main component is silicon dioxide because glass is made by silicon dioxide, made by sand, silica。玻璃是用，还是玻璃是用沙做的？OK，它的那个最主要的成分是沙，我们叫做 silicon dioxide。OK，and then question 30, page 31. This one is also Form 4 chapter. I mean, not 31. Form 4 31. Form 4 chapter 8. Diagram 11 shows the apparatus setup of an experiment to study the hardness of copper and bronze. Okay. Normally, bronze 它是一个 alloy 合金。Okay, it is an alloy. Okay, normally hard alloy it is harder material compared to the pure metal. Copper is a pure metal. Bronze is copper added with another metal called tin. Okay, to make the bronze become stronger. So this experiment, you see, first they use bronze block, second they use copper block to see which one the diameter of dent is higher. They will drop a weight, okay, onto the steel ball to see how much the curve is, how much the diameter of the curve of a dent. So if the diameter is deeper, is higher, means normally the material is a bit weaker, it's a bit softer, not hard enough. Normally it's copper lah, it's a pure metal. 这是纯金属啦 ，okay, like this, okay, this is pure metal 纯金属 ，not strong enough. 纯金属是弱过合金的。Pure metal is normally weaker than alloy. So you see, which statement best explained? Okay, bond between atom in bronze is stronger. No, it's not about the bond. Nothing to do with bond. The empty spaces between atoms in copper are bigger than bronze. No, there's no empty spaces. Okay, both have occupied everything because it's not like empty space. Empty spaces. B could be, but B is not the best answer. Okay, actually, it might have empty spaces, but it's not the best answer. Okay, normally you explain in theory is C. C, because the foreign atom. You said let's say I know, right? This is copper. Copper, right? Copper have all the same size. This is copper atom, copper metal. But the big problem is when you apply the force. When you apply the force, it can easily get broken. Also, not broken, but easily slide over and become dent. Okay, so let's say your table. Let's say this is your table. I know it's a table. Your table, where you knock too hard. Let's say the table made by copper. Knock too hard. There's a curve like this. Okay, so the whole thing become very ugly. Okay, because it's not strong enough to resist your force. But if bronze means, you know, right, the structure how to draw it. You added 10% of tin inside. Maybe you added 1 or 2 atoms of tin. Let's say just now all these are copper. Now copper added tin. In this case, when you apply the same force, when you apply the same force, this thing won't easily get broken, won't easily get dented, won't easily change shape. Okay, because this thing is stronger material. Okay, that's why you call it for bronze. When you add the foreign atom, it means different atom like spin, make it very difficult to slide over each other. Sukar in Malay suka menggosok antara satu sama lain. In Chinese means 如果你大大力去打这个纯铜啊纯金属，很容易换形状的。OK, easy change shape. OK, 它会凹进去，太大力的话。但是合金，OK, 你的 alloy, 你的 bronze 这个青铜，大力打的话，它没有这么容易凹进去，因为它那个 atom 很难走位，很难 slide over. Okay, so you understand? So not easily slide over. Okay, so form 4 question 21 form 4 chapter 8. Oh, this is a bit hard. Okay, this is a bit tricky. So this is ceramic. Okay, so diagram 12. Okay, shows Amina get a treatment about dental implant. What is the type of ceramic used in the treatment? Okay, this one is zirconia ceramic. Probably I know this one I didn't much. Okay, but this one is A. 31 is A. Yeah. Normally, alumina and the tradition is the same. Okay, so these two are the same. Okay, because if ceramic made by alumina actually, okay, it's called aluminum oxide. So normally used for like pots, to make pots, bricks, okay, all this yeah, bowls, example. Okay, ceramic in Chinese 陶瓷做你的碗、砖块、花盆那些啦。Okay, and then advanced ceramic, they add some modern chemicals. Okay, chemicals like silicon carbide, tungsten carbide. Okay, to make like break this. Okay, it's like a CD shape. Sometimes I don't know if you have seen that. Okay, it's not CD, but this thing can be used to cut a very very hard material. Okay, like your Bercy, all this like your iron. Okay, like your Bercy, like your very hard metal. Okay, can cut lah. It's a bit sharp one. I don't know if you have seen. Okay, or no. This one is cutting this. Sorry, this one is cutting this. Okay, cutting this in Malay it's called cakra pemotong. Okay, so cakra pemotong. Brake disc is like your motor there, your car consists of brake disc. Brake disc. Okay, so I know you haven't driven a car yet, but if you drive a car, maybe like if you drive a lot, maybe you have to change a lot. You have to change the brake disc every 1 year so 1 or 2 years. If you not drive so frequently, maybe 2 or 3 years, you have to change your brake disc because your brake disc will go through a lot of friction. Okay, when you drive on the road. Okay, but this one is for dental implant. All this. Okay, so it's A. But don't worry, this one is okay if you're wrong. Okay, this one is a bit tricky question. Okay, there are a lot of type of ceramic okay, which can make like installation of wall, okay, dental implant, all this But again, this one is also part of memorization for the uses of ceramic. Okay, question 32. Form 4 chapter 6 calculation. Okay, so Aina memperoleh 0. Okay, Aina obtained 0.05 mole of magnesium nitrate from the reaction between magnesium ribbon. So 0.05. So you straight away can say that magnesium nitrate is 0.05 mole. Straight away got information. Write down first. Okay, magnesium nitrate is MgNO32. From the reaction between excess magnesium ribbon with 50 cm cube of nitric acid. Okay, write down. Which one is nitric acid? HNO3. So write down the volume 50 cm cube. So they ask what is the molarity. Very simple. So they ask to find M, molarity. So they give you V. So obviously they have to use MV of 1000. But now you must be this information are very simple. Since they already give you the mole, don't forget one thing, do ratio. So you got two steps. All right, for you. First step, cari nisbamu. Here you got two steps. In English, it's called find mole ratio. Find mole ratio. Second step, find in Malay, sorry, in Malay is cari kemolarity. It's called find molarity. So you only have to use one formula here. The formula is mole equals to MV over 1000. Right? So, but first step, ratio magnesium nitrate to nitric acid. So you see, what is the ratio here? 1 mole of magnesium nitrate to 2 mole of nitric acid. 1 mole of magnesium nitrate to 2 mole of nitric acid. So if you got 0.05 mole of magnesium nitrate, 1 times 2, 1 times 2 become 2, 0.5 times 2 become 0.1 mole of nitric acid. So you have to use this information. First step. And then only second step. Number of mole equals to MV over 1000. Since you want to find V, so mole equals to MV over 1000. So if you want to find V, how? What should we do? Make V as a subject. You learn in mathematics. Make V as subject means you move 1000 to the other side become times 1000. You move M and V is times, right? But if you move to that side, become divide. So mole times 1000 divide V. And not divide M, sorry. Molarity. So because we want to find V, right? So mole is 0.1 times 1000. Molarity is, sorry, don't find molarity. I am so sorry. I'm confused. Okay. Molarity. So means divide V, sorry. Do they give you volume? Oh, yes, 50 cm cube. So it's 50, because the thing is, MV means M times V. So if you move the V to the other side, you will get divide V. But 1000 is V divide 1000, move to the other side, become multiply. Mathematics, So you will get Let me calculator. 0.1 times 1000 divided 50. 2.0 mole per cube. So that's C, right? Am I right? 32 is C. Correct. Correct. 33. This one is Form 4, Chapter 7. Diagram 13 shows a graph of volume of carbon dioxide gas against time for two experiment 1 and 2. Okay. So table 6 shows the condition of reactant for both experiments. So you see, you observe carefully the graph. Okay. So the graph, okay, the graph got two parts. Number one part, volume of gas. Okay, you see, do you know what does it mean like this? You see, became constant means the reaction has finished. 就是它的 graph 如果变成 constant 变成值的话，它的 reaction 已经完成了。Okay, so it means when you see, which one become constant first? Means using shorter time to finish. Means have higher rate of reaction. Okay, so which one using shorter time? Second. So second means, okay, it means second reaction has the higher rate of reaction because, or you can in Malay is kada tindak balas yang tinggi lah. Okay, because second using shorter time to finish. It means first one slow to become constant. First one rate of reaction lower. This is the first part of the graph. Understand? It means it must have one factor that cause second reaction to be faster. I mean, don't say faster, say higher rate of reaction. First one, lower rate of reaction. Okay? Kada tidak rendah. Okay? So, second part is about this part. You see, you see properly. First, second, you see the similarities. They ended they ended at the same height. Same height of what? Same height of volume of gas. It means you will get the same amount of volume of gas. Then I don't know. I don't know. I get V. I don't know. Okay. So you get both. You get V cm cube of the gas. Okay. So here probably you do you know what is the gas? Marble is calcium carbonate. React with hydrochloric acid. So you already know. Okay. Normally, if you see carbonate react with, if you see carbonate react with acid, normally you will get carbon dioxide. Normally you get volume of carbon dioxide. So in this case, okay, you see VCM cube is equal. Normally if you see the side ended with the same height 它的那个高度是一样，right？ 它的 ending 结束高度是一样 ，means the number of mole for both, for first one, second one, for first one is equals to number of mole of second one. Number of mole for first equals number of mole of second. So that because if you have to get number of mole same, so that your volume of the first one also can be equals to volume of the second one. Because you know, right? Normally you do number of mole equals to volume over molar volume. See, molar volume cannot change. It means both must be constant. 24 dm cube per mole normally in room temperature. So normally you change volume or number of mole. But if your volume of gas produced same, your number of mole also should be same, right? So another one, you see, in order to get number of mole, right, you see, they will give you like this to confuse you. Now, in this case, you see properly. So the funny thing is, some students very confused with this. Okay, so you see properly. I do one by one to you. Let's say the first experiment. Okay, 50 cm cube and 0.5 mole cube. They give you volume molarity. Now, just only we did not long ago. The formula for mole is mv over 1000 for this acid. Right? So let's say I want to find the first one. Number of mole of HCl in one. Okay, I'm talking about the first one. I'm talking about the first experiment. Is mv over 1000. The m is 0.5. V is 50 divide 1000. So you will get, let me see, 0.025 mole. 0.025 mole. Let's say this one is room temperature. Then if I want to get the volume of carbon dioxide, then I use 0.05 times 24. Let's say the molar volume 24. Because you know, right? Another formula for number of mole is volume divided by molar volume. In Malay, is isi padu divided isi padu molar. Right? So another one is just now, right? MV of 1000. So after you use this, it means after you use this formula to get number of mole, then from number of mole times molar volume, then you will get volume. So let's say your volume, you will get around like 0.6 dm cube. But okay because here is cm cube, normally use cm cube, right? Let's say times 1, because, okay, again, because 1 dm cube equals to 1000 cm cube. So let's say you get 600 cm cube of gas. Okay, so for the first calculation, see, I do the long way so that you understand what happened. Okay, so because this kind is very confused if you don't understand. Okay, so you see, the second they give T cm cube and U mole per cube, they ask you to suggest which one is correct. Okay, so you think properly. You see, it means here you use the same acid, so you cannot be more. You won't be affected by monoprotic or diprotic. Not possible. Okay, so in this case, the only thing, because the ratio, okay. So actually, it's not 600. By that, it's not 600. I forgot one more ratio. You see, this question is like take a lot of time. Okay, so okay, the equation, main thing I left. The equation is calcium carbonate react with hydrochloric acid. Okay, I write for you. Balancing means times 2 for HCl because you got 2 H2Cl at the right. Okay, so it means the ratio is 2 to 1. 2 to 1. Okay, it means 2 mole of HCl to 1 mole of CO2 lah. Then 0.025 of HCl to 0.0125 mole of CO2. Okay, let's look at this. After divide by 2 lah. It means here I will get like 0.3. 300 cm cube. Okay, let's say 300 cm cube is the correct answer. So it means if the first one you get 300 cm cube, the second one you also get, supposingly, you also get 300 cm cube. Supposingly, right? Because the graph shows it's equal. Not like 2v, no. Right? So you see, I use because this one is M, this one is V. So let's say I use A. You just see properly. This one is gonna be very long question. Okay. I do shortcut, okay? So A 0.5 times 10 divided 1000. This one take a lot of time. 0.005. Actually, in calculation, in shortcut, in exam, no need to do so long. But I tell you because I have to tell you from the start. If not, you won't understand what's happening. So 0.005 more. Then divided by 2 for ratio, you will get 0.0025 times molar volume 0.06, which we get 600 cm cube. No, you do until here. You see, you do until here, you already know the mole is not equal. It means no, you do until here. I do until here already, I know lah. Okay. If I don't get 0.0125 mole, wrong. Right? So A is not correct. Now, but don't forget to consider the reason second has higher ROR. Most probably because you increase the concentration. It means just now the first one you use 0.5, right? It means second cannot, can be 0.5? If the first one use 0.5 more per m cube, of course the second you have to increase to 1.0. So it means the answer should be either B or donkey, isn't it? Better. So actually, don't even have to calculate for A and C lah. If you are smart about it. Okay. And let's say I calculate 20 times 1.0 divided 1000. I'm sorry if I stay too long for this question, but I try to explain. Okay. So 20 divided 1000. 0.02 divided by 2, 0.01. After the ratio lah, because the ratio is 2 to 1, right? So do you think makes sense? No. So it cannot be B also. So it cannot be donkey. Why? You see properly. 25 times 1.0 divided 1000. Sorry, 0.025 more. Ratio divided by 2. Then the answer is donkey. So because if you multiply these two, divide 1000, you will get the same mole as the first experiment. You get as a first experiment. Answer? Okay. In summary means the first experiment for number of mole of carbon dioxide is 0.0125. Okay. For the donkey one, you also get 0.0125. So both volume produced, you get 300 cm cube. For 1, for 2, final, the height. But condition, you increase the real reaction for second one. So you cannot, If the first one use 0.5 mole per dm cube concentration, of course the second one have to increase so that it can use shorter time to complete. Yeah. Question 34. Form 4, chapter 8. Diagram 14 shows information about a composite material. What is X? This one is YbCO. Okay. This one is the YbCO. Urea 3 carbonate, barium carbonate, copper 2 carbonate, oxygen. No electrical resistance at a very low pressure, low temperature. This is superconductor. This is 8.4, chapter 8.4, composite material. Composite material got 5. Go and look back. Okay. So you got fiberglass, optical fiber, superconductor, photochromic glass, reinforced concrete. Okay. Go and look at the uses one by one. A lot of uses. Okay, I tell you lah, fiberglass can make like tanky water. The plastic normally it's plastic. It's like a very strong plastic to make like a badminton racket lah. Okay, I don't know racket lah. Water tank a lot of example lah. Okay, and so on. Optical fiber normally make your TV cable, Wi-Fi cable. Superconductor normally make your the MRI scanner. Okay, MRI scan, MRI machine. Okay, or the super magnet one, super magnet on the bullet train. Okay, for the common glass, just like I told you, right? The sunglasses, the car window glass. Okay, the camera lens. Okay. So go and look back the uses. Okay, 8.4 composite material. Okay. And then question 35, form 4 chapter 1, form 5 chapter 1, sorry. Oxidation number of sulfur in thiosulfate ion. Okay. So very easy. You see, S2O3, the total is 2 negative charge. So it means total must be negative 2. But let's say you don't know what is S, so you put 2S because you got 2S. 2S plus 3O. What is the charge for O? Oxide. O is O2 minus, so it's negative 2. But here you got 3O, means plus 3 times negative 2. You will get negative 2 overall. So you just find S answer already. This is very quite easy question if you know how to do it. Okay, so 3 times negative 2, negative 6. Negative 6 move there, positive 6. So 2S equals to after negative 2 plus 6, you will get positive 4. So then, let me show you the step for those who confused. 2S equals to negative 2 plus 6. You get 2S equals to plus 4. S equals to positive 2. So the answer is B. 36. Form 5, chapter 1. Okay, this one is arranging oxidizing agent and reducing agent. This part, okay, is very simple actually if you know technique. Okay, so if you see, if they are in reduction form, receive electron, menerima electron means dia ini bentuk penurunan. They are in reduction form. Okay, so but you see, this is not arranged properly. Please arrange properly. If you see, arrange means from smallest to biggest, from most negative to most positive. So which here they didn't do a good job. Okay, so you arrange again. Very simple one. Okay, so you arrange again. Arrange P2 plus. You will get P. Okay, not P first. Most negative one is R. So I arrange R first actually. R2 plus 2E minus become R. Negative 2.67 volt. This one is negative, not P first, P is last actually. So after that is Q first. Q3 plus 3E, negative 1.66 volt. Then only last is P, positive 0.85 volt. So then what you do is you arrange properly already, most negative to most positive in order. You ignore this here, arrange in order. Then left side is oxidizing agent, right side is reducing agent. First, you must arrange first. Then only weak, strong, strong, weak. Because the agent from weaker becomes stronger in order. Going downwards. This one reducing agent terbalik from bottom to upwards. From weakest to strongest means up, bottom to top. So they ask to arrange in what? Arrange the strength in ascending order. Ascending order here means weakest to strongest. So for oxidation agent, which one is weakest? R2 plus, Q3 plus, then P2 plus. Then reducing agent, PQR. So the answer is donkey. Once you know the technique, it's kind of technique okay, to arrange to get the strength of oxidizing agent and reducing agent. Yeah. I know your brain already explode. No worry, okay? If you today you already lost, for those who watching video or for those who of those who are still here, okay? It's okay. Okay. Later I send the video and you watch back again. If you today feel lost already. I know your brain cannot enter too many things once. Okay, so if you're free later on, I'm sure you're holiday now, but you can take your time to watch the video again if you feel lost. Okay, because sometimes you cannot, if I say once, you don't understand. Okay, but you have to repeat to listen a few times, then only can understand. Okay. It's like that one. It's very normal. Okay. And then, unless you know the concept already, that's different. Question 37, Form 5, Chapter 1. This one is to study the conversion between Fe2 plus and Fe3 plus. Okay. So, normally, Fe2 to Fe3. Fe2 plus will donate 1 electron to become Fe3 plus. Donate electron means what? This is oxidizing agent. It's an oxidation reaction. Oxidation reaction. So, let's say you have iron 2 sulfate, which is containing Fe2 plus ion. Okay. How do I convert this to Fe3 plus? What do I have to add? What do I have to add? I have to add an oxidizing agent. 就是 in Chinese means 如果你要让 Fe2 加变去 Fe3 加，因为 要怎样让 Fe2 加进行 oxidation，你就要加一个 oxidizing agent，因为它的作用是可以 oxidize Fe2 加变去 Fe3 加。It means what is the function of oxidizing agent? Remember, because you can oxidize to make sure Fe2 plus can oxidize, become Fe3 plus. Okay, so what are the example of oxidizing agent? What is W? Okay, remember acidified potassium manganate. 7 solution. Acidify potassium dichromate 6 solution. Chlorine water, bromine water, or any Fe3 plus salt. Reducing agent Ki, KBr, or any Fe2 plus. Like this, actually Fe2 plus here act as an reducing agent. So which one is oxidation? Chlorine water. Answer A. But you have to memorize, right? Okay. The aim is how to make Fe2 to undergo oxidation to become Fe3 plus. You have to add an oxidizing agent to make sure Fe2 plus can undergo oxidation. Yeah. Because okay, just 3 more. Question 38. Form 5, chapter 1. This one is an easy question. Okay, very easy, but still people got wrong. Okay, because I have to mention one more time. Okay, so the formula is E naught cell equals to E cathode minus E anode. Now, I know people won't remember this formula, most of you. Okay, so it's okay. Okay, even if you terbalik, make sure you have to think you have to think the voltage, right? Your voltage must get positive value. Your voltage is like a battery. Your battery should contain positive value, not negative. No negative answer. Final answer, no negative. Okay? It means you use, what is voltage, right? You use positive 0.34 minus negative 1.66. So you get positive 2.00 volt. But a lot of people circle this one. Even I know some of you terbalik the minus, then you will get negative 2.00. But no, this okay. So no, please no negative. No negative. Okay, E naught value, no voltage, no negative. Right answer. It means if you get negative, means you use wrong formula terbalik. Okay. Question 39. Form 5 chapter 1. This is kind of a tricky question. Okay. So we are studying the electrolysis process for solution Q with different concentrations. Okay. What solution Q can produce different products at the anode when the experiment is carried out? Ooh, okay. This is the challenging question. Okay. So they are doing electrolytic cell. So in this case, you always have to identify what are the ions available. I told you, right? N ion go to anode, cat ion go to cathode. This kind of thing, right? Then the anode and the N ion will be, which one will be oxidized? Then the cat ion, which one will be reduced? So you see, I want anode. I don't care about cathode now. So have different product menghasilkan hasil timbras yang berbeza. The anode. Okay. So you see, one by one, look, all they give you acid. So you see, okay, A, hydrochloric acid contain what ion? Remember, we also learn Form 4, Chapter 6. You always have to put inside, you have to put this acid inside water. Then only acid can ionize. You see, water got H2O, got two ion, got H plus, OH minus. It means what are the three ions inside this? It means inside this contain H plus in H plus Cl minus OH minus. B, sulfuric acid. What ion? Probably we produce 2H plus and H plus H plus. Then you will get sulfate ion and hydroxide ion. Okay, everything got water. Okay, because acid must have water to show its acidic properties. C, carbonic acid is H2CO3, contain H plus and CO3 2 negative and OH minus. We don't learn much about carbonic acid because carbonic acid is very unstable. Normally, this acid we quickly decompose into carbon dioxide and water. So normally we don't learn carbonic acid. Donkey nitric acid contain hydrogen ion, nitrate ion, hydroxide ion. You see, okay? Normally in this situation, what is happening? Now, in this case, normally what do you what is a factor that will determine which ion will be oxidized? Three factor, right? I told you, right? First one is called uh, the type of electrode. In Malay is Journeys electrode. Okay. Normally you got electrode active electrode used like either copper or silver in our syllabus. So normally you choose if let's say these two, the anode is copper or silver. Normally you don't choose the ion instead. You choose copper or silver to undergo oxidation. Right? What is the second one? The second one is concentration of halide ions. Like what? Normally, I told you, right? Have to be concentrated, or normally they say more than 0.5 mole per DM cube. Normally, like what? Like if they got Cl minus, Br minus, or I minus ion. Normally, you have to choose the ion if the concentration is equals to or more than 0.5 mole per cube. Right? Then only look at E naught value is more negative. Or in the sense that less positive. Yes. So you see, the problem is you know which one, right? Normally, all of this you choose H plus because we only got H plus. All the H plus here will undergo reduction. But which one will undergo oxidation? Now, in this case, you see, normally the second factor, if the concentration is more than 0.5, what ion do you choose? I talk about second factor. You see, here got Cl minus hydrochloric acid. So if it is equals or more than 0.5, you will choose Cl minus to undergo oxidation to get Cl2. Correct? If the concentration is less than 0.5, do you choose Cl minus? No. Then you follow the third factor because OH minus is more negative. I would say less positive. Do you know what is the inner value? Yeah, I know what you memorize the inner value, but I try to set out the inner value. Give me one. I'm trying to find out the inner value. E not value minus. Give me one. 1 minute. Because nobody really go and memorize the ion, but the inner value. But I just want to show you, okay? Okay, so okay, normally Cl minus is positive 0.40 volt. Uh, normally, no Cl minus, OH minus, sorry. OH minus, normally the Cl minus is positive 1.36 volt. Okay, but in this case, what happened is for all the like sulfate, carbonate, nitrate, normally they are also more negative than OH minus. They are negative 1 or negative 2 something. Okay, so they are more negative. Doesn't matter. Okay, a lot of these are more negative than OH minus punya inner value. So you see, all these three. Do you think normally they will choose these three? I'm sure you learned in Form 5 Chapter 1. Have you ever choose this ion to undergo oxidation? No. They are very difficult to undergo oxidation because all of them have more. Sorry, have are more positive. Sorry, all of them are more positive than OH minus. I should write here. More positive than OH minus, including Cl minus also. Right? Normally, all these ion, if you compare to OH minus, you don't choose the other one. You always choose OH minus. You normally don't choose this. Normally, 100%, you don't choose sulfate, carbonate, nitrate compared to OH minus. You always choose OH minus to undergo oxidation, become oxygen gas, including when the concentration of Cl minus is less than 0.5, you also choose OH minus to produce oxygen gas. Right? There is no other choice because the second factor cannot apply to sulfate, carbonate, nitrate. Not possible. But it can affect chloride ion. So it's like sometimes in this hydrochloric acid, sometimes it can produce Cl2. That is why they say which one have different product. The possibility of having different product is A. So answer? This question is a bit funny. Okay? Yeah. So you have to use the brain to think a bit. Okay. Okay, last question 40. This one is easy question. Form 5 chapter 1. Okay. Arrange XYZ in descending order of electropositivity. Now, descending order means from most electropositive to less electropositive. Hey, you know, right? What does it mean by electropositive? Electropositivity means tendency to donate electrons. Normally, like potassium, sodium, calcium, magnesium, aluminum, zinc, this few, right? Normally, they are very easy to donate electron compared to iron. Okay? So it means all these, they are more electropositive than iron. And you can see they got like pink spot, blue spot, blue spot. Blue spot, you see blue spot, right? After they put potassium hexacyanoferrate, which is to detect the presence of epitopus, means it shows that iron has rusted. Very simple. If you see blue spot in this experiment, in this iron experiment, if you see blue spot, iron has rusted. 如果你看到有蓝色的 spot，代表那个铁已经生锈了。OK， 因为你放了这个东东，可以侦探到 Fe 二价的存在。Okay, you put this, you get the presence of to see whether Fe2+ present or not. Okay, pink spot means if you put phenolphthalein is to detect OH minus. This one just to tell you, iron does not rust. Instead, the protector rusted. Okay, the protector rusted. Let's say iron coil, iron near coil metal Y. Y is the one that rusted to protect iron from rusting. It means 如果放 phenolphthalein 的话，有 show pink color 代表里面有 oxygen，代表你的铁钉没有生锈。Instead 保护它那个 Y 生锈了，Y 就变成 Y 二加了。So normally 这样子的话，就代表 Y 是比 iron electropositive. Normally like this means tell you Y is more electropositive than iron. Okay, Y probably can be either can be magnesium or aluminum or zinc lah. Small amount of blue spot means normally near iron, but less electropositive than iron. It's like tin or something lah, tin or lead. You know the reactive metal. For I read one more time for those who still don't know. Normally I tell you these three don't use in experiment because too reactive. These three normally more electropositive than iron. Means can protect iron from rusting. Okay, can protect iron from rusting. 这三个是比 iron electropositive 的，它们可以保护铁钉不要给它生锈。Normally the bottom one, bottom four, tin from tin to silver, less electropositive than iron, which cannot like metal X cannot protect iron from rusting. 就是这四个 tin, lead, copper, silver 是没有办法保护铁生锈的。它可以加快，反而加快铁钉生锈速度It will not help to protect iron from rusting. It will speed up the rusting of iron. Okay, so it means you have to arrange from here to here lah. So arrange X, Y, Z iron, 4 things. So normally, of course, the Y is the best example. Y can protect iron from rusting lah. So Y first, Y then iron, then the small amount first. Small amount means the rusting is a little bit only, not that serious. Normally, if like tin or lead, right, normally rusting a little bit only. If you use copper or silver, the distance very far, then rusting a lot, rusted a lot. Okay, because the distance very far. 如果你 normally 用那种比较远的 copper 跟 silver 的话 ，connect 与铁的话，它的那个生锈率比较高的。如果 normally 用tin 或者是 lead，生锈率比较低。So in this case, normally now is Z, then only final is X. So the answer is C. Yeah, this is question 40.